This conference will now be recorded.
Hi, my name is Ann Scanello, and today I'm going to be talking to you about how to solve simple equations, no more than 1 or 2 steps. I'm working with the Seeds of Literacy people. This is a video lesson, and I've addressed 2 specific packets, the Algebra Number Power book from the Number Power book and Algebra Contemporary. And there we go. I'm not going to do the entirety of either one of the packets as they are listed on the resource pages. The Algebra Number Power book, I'm going to be looking at pages 59 through 71. The Algebra from the Contemporary book, I'm looking at pages 3 through 9. And if you have the packets, they actually kind of look like this. Or if you don't have them, these are the packets that you could pull later. Some of you, I thought, might be watching this lesson, even though you may not have reached algebra yet. If that's the case, there are some really good videos that give a basic understanding of kind of the lesson that I'm about to teach. It's a total of about 21 minutes, but they are both on YouTube, and it's the Math Antics group that puts them on. They're kind of goofy and silly, but I personally would rather have things made really, really simple rather than have someone speak over my head. Today in the lesson that I'm about to show, we're going to do a couple of things. We're going to solve simple one-step equations. We're going to look at how to do that when we're adding, subtracting, multiplying, dividing. We're going to work some problems with fractions, and we're going to work some problems with decimals. After that, we're going to look at some two-step equations. And then we're going to learn how to use substitution to check our problems. When I'm looking at solving equations, I really like to think of it as it would be on a balance beam. This is supposed to be a picture of a balance beam like you might have seen in a science class many, many years ago. The idea is that you've got 2 plates here, and so long as the weight on the plate on the left is equal to the weight on the plate on the right, the balance beam will stay straight. If you get too heavy on one side or the other, the balance beam is going to start to tip. So same thing with equations. Our equal sign represents the balance beam. So the equation that we're going to look at, the first equation, is x plus 3 equals 5. And you can see they've built that over here with manipulatives. They've got a block representing x and then 3 ones. And then this is the equal sign. The balance beam is the equal sign. And then it equals 5. And so you can see that there's 5 ones. Because the balance beam is level, it's completely horizontal, then that tells you that the weight or the value on the right side is exactly equal to the value on the left side. So we want to simplify this. We want to solve the equation. And so we're allowed to add things or take things away, but whatever we do, we have to make sure that we do the exact same thing on the left side as we do on the right side. So we can see that we have got ones on both sides, so we could take off 3 ones from both sides. And so here is the solution being modeled. So I took off my 3 ones, exact same thing from both sides. My balance beam is still level, and I'm left with an x on the left side and 2 ones on the right side. So that's how they've modeled that x equals 2. So our original equation, x plus 3 equals 5, we simplified it by removing the same thing from both sides to come up with our solution, x equals 2. So I like that analogy because I frequently will refer to the balance beam representing the equal sign. And the most important thing you remember is that whatever you do to one side of the balance beam, we do to the other side. Okay, for the rest of the lesson, I'm hoping to show problems on my whiteboard. Okay, so now I'm going to ask you guys, Todd and Tashonda, can y'all see my whiteboard fairly well?
Yes, we can. Very much.
You can see it and you can read what I'm doing. Excellent. Okay, so I'm going to try a simple problem. This is very similar to what we just saw on the last slide. Simple addition problem. Z plus 17 equals 35. First thing I do is I put down my equal sign to remind myself that whatever action I take next, I have to do the same thing on both sides. When I'm finished with the problem, I want Z all by itself on one side of the equal sign, and I want a value or a number on the right side.
We got motors over here.
Right now it's plus 17. In order to cancel that plus 17, I need to do the opposite operation,
Subtract 17.
minus 17. So I'm going to subtract 17
On that
from both
side.
sides.
We cross that out, and now Z by itself.
I still have my Z. Plus 17 minus 17 will cancel, and I'm left with 0. A lot of students like to put the plus 0 there. I don't like to do that because honestly, it just adds an extra step. So I'm going to erase that now because we know that Z plus 0 is the same thing as Z. So now we have to do 35 minus 17. 5 minus 7 can't be done. I'm going to borrow from my 3. 15 minus 7 equals 8. 2 minus 1 equals 1. And there's my answer, Z equals 18. Now, I forgot to say that problem, in case you wanted to look it up later, is on page 60 of the first packet. That was problem number 2. Okay, Tashonda, as I work these problems, I'm going to write the problem up there. And it sounds like, are you working along with me on paper, or by any chance do you have the packets?
Paper.
Okay, that's fine. That works great. The next problem would come from page 61. It's problem number 1. It's Z minus 15 equals 32. Now this is similar, but remember our goal is to end up with Z equals our answer. And so we've got, along with Z, the minus 15. So we need to ask ourselves, what's the opposite, or what do I have to do to cancel out the minus 15? And so that would be plus 15. Remember, whatever I do on the left side of the equal sign, I do the identical action on the right side. Minus 15 plus 15, I know that's going to cancel. I can bring down my Z, bring down my equal sign. I like to keep my equal signs lined up. 32 plus 15 is going to equal 47. How are you coming, Tashonda?
Good.
Okay, let's keep going.
All right.
I wanted to try some word problems because I know that it's the exact same concept, but when we get to word problems, that somehow makes things more confusing. If someone had the packet, this is on page 62 of the first packet that I talked about. It's problem number 6. It says, Blake had a full bag of cookies. After giving 14 cookies away, he still had 19 left. Write an equation to find the number of cookies, N, that were in the bag originally. And they want you to write the equation, and they want you to solve for N. So they've already decided that the letter variable we're going to use is N, and that's going to represent number of cookies. Okay, so let me see. Let's read it again. Blake had a full bag of cookies. And they've already told us that we're going to use N to represent Blake's full bag of cookies. After giving 14 cookies away, so that's kind of like take away 14, original bag of cookies, taking away 14 cookies. He still had 19 left. This is our equation. Now all we have to do is solve our equation to find out how many cookies he started with. Subtract 14, well, the opposite of that would be plus 14. Remember our balance beam, we need to add 14 to both sides. Minus 14 plus 14, that's just going to cancel. All I'm going to be left with on the left side is an N. 19 plus 14, 9 plus 4 is 13. 33. Started out with 33 cookies. Let's move on to one-step equations that involve multiplication. This problem is on page 63 of the first packet. It's problem number 4. And it's 5y equals 32.5. Okay, now remember, when I'm finished with the problem, I want to end up with y equals a number. And I already have y on the left side, but it's currently being multiplied by 5. So I need to ask myself, if I want y all by itself, what do I need to do? How do I undo multiplying by 5? So the opposite operation from multiplication would be division. And I'm going to represent division today using the fraction sign. I know many of us are used to seeing division written like that, but when we get to algebra, we typically use the fraction sign instead. So I'm multiplying by 5, and so I want to divide by 5 to undo that 5, or to get that 5 to cancel out. Don't forget your balance beam, your equal sign. If I divide by 5 on the left side, I do the identical operation on the right side. Well, on the left side, 5 divided by 5, that's just going to equal 1. But don't forget your y. We still have y. I'm going to put my equal sign, keeping them all lined up. But now I have to solve 32.5 divided by 5. And I'm going to use my little scratch paper over here to do that. Okay, so I need to say 5 goes into 3. Well, it doesn't go in there at all. 5 goes into 32 6 times. I know that 6 times by 5 equals 30. I'm going to subtract and end up with 2. Now I'm going to bring down my next digit, which is a 5. 5 goes into 25 5 times. 5 times by 5 is 25. I'm going to subtract, and I'm going to end up with 0. 65 doesn't sound right. And I realize I forgot to mention one really important step when we're using long division. Before you even start to solve the problem, you can go ahead and place your decimal point where it belongs in the answer. It is directly above its starting position. 6.5, that makes a lot more sense. 5 times by 6.5 would equal about 32.5, sure. Now here, when I divided 5 divided by 5, that answer was 1. And so I wrote 1y equals 6.5. That's absolutely correct. There is nothing wrong with that answer. But typically, we don't write our answer that way. We don't format it that way. We should understand that 1y is the same thing as just saying y. So you will almost always see the answer written like this. Okay. The next problem is from the first packet, page 64, number 3. And now we are dividing. Okay, so right now, I'm thinking to myself, I want to end up with n equals a value. Right now, n is divided by 6. If I want that divided by 6 to cancel out, I need to do the opposite operation, which of course is multiplying by 6. Don't forget your balance beam. If I multiply the left side by 6, I'm going to do the identical thing on the right side. Okay, well, this n divided by 6, well, that's a division problem. By the way, that is still a fraction. And when we're solving problems, we can just regard that as a fraction. And so this fraction of n divided by 6, if I want to multiply by 6, it's going to be easier if I write them side by side. So I'm just going to kind of cheat and put 6 times by n divided by 6. And of course, when I'm multiplying fractions, I always want to have a fraction multiplied by another fraction. So I just put my 6 over 1. Now I can cross simplify. Both of those divide by 6, which leaves me with a 1 and a 1. So I'm left here with 1n over 1, which is the same thing as just saying n. It's like what we had before. This is correct. It just looks weird. This is proper formatting down here. But we're not finished yet. We still have to deal with 2.5 times by 6. Let's multiply. 6 times by 5 is 30. 6 times by 2 is 12, plus 3 more is 15. 150. Huh, that doesn't look right. Again, don't forget about your decimal point. When I'm multiplying, I multiply as if the decimal point didn't even exist. But when I have my answer, I have to go back and I find the decimal points within the two numbers, and I see how many digits there are to the right of the decimal. There is this 5 is to the right of a decimal, and technically there's a decimal right there, but there's no digits to the right of it. So in the problem, there was one number to the right of the decimal. In my answer, there will be one number to the right of the decimal. So the answer is 15. Tashonda, how are you coming?
Good.
Okay. Let's try another word problem. This one, if you had the packet, is page 65, number 6. It says 1 out of 8 students are sick with the flu. And I did not make this up. It was actually in the packet. If 4 students are sick, how many students are in this class? This time they want us to write the equation and solve for the number of students in the class. And again, they chose our variable for us. They said, let's use the letter n to represent the number of students. In algebra, on a problem like this, typically we get to choose the letter we want to use to represent the problem. You could have used the letter S to represent number of students. You could have used the letter T to represent total students, so long as you make it clear what your variable represents. Okay, they're saying we're using n, so we're using n. So we know the total number of students in the class are n. And it says 1 out of 8 students are sick with the flu. So 1 out of 8 is just the word way to write out the fraction 1/8. Okay. Are sick with the flu. If 4 students are sick, how many students are in the class? Okay, there's a little, I don't know if I would call it a trick, but it's when we're turning words into a number sentence, there are some things to know that will make it much easier. And one of them is the word of. Of translates to multiplication. Say multiplication. And so if you can state a problem using the word of, really good chance that our operation is going to be multiplication. So I'm thinking this problem, let me see, 1 out of 8 students are sick with the flu. So it sounds to me like 1/8 of the class. So 1/8 of the class. I could put my little multiplication symbol or my dot in there, but again, in algebra, proper form is to just leave that out. And you're typically going to see the number directly in front of the variable, and you're just understand that that's multiplication. This number, by the way, is called the coefficient. So you might hear that term. They might say something like, what is the coefficient of the variable in this problem? All that means is what number is in front of the variable. But then we still have to solve this problem. 1 out of 8 students are sick with the flu. If 4 students are sick, so 1/8 of our class wound up being 4 students who were sick. So now we have to solve. This one's a little trickier because we're multiplying by a fraction. So n multiplied by 1/8, if I want to get to n equals an answer, how am I going to undo multiplying by 1/8? I have an idea. Let's divide by 1/8 because division is the opposite operation of multiplication. Don't forget your equal sign, your balance beam. If I did it on one side, I'm doing it on both sides. Okay, so if you remember dividing by a fraction, we actually multiply by the reciprocal of that fraction. And if you don't remember the term reciprocal, I call it the flip-flop. We just flip-flop the fraction and multiply. So 1/8 divided by 1/8 is the same thing as 8/1 multiplied by 1/8. Okay, well, I can do that because I can cross simplify. Both of those divided by 8 leaves me with ones. Oh, look, I've got 1n/1 again, but I know I don't have to write that out. 1n/n is just the same thing as n. But I still have to solve this side. 4 divided by 1/8. So I need to multiply by the reciprocal of 1/8, which is 8/1. I'm going to turn my 4 into a fraction because it'll make it easier to see how to do the multiplication. 4 times by 8 equals 32. 1 times by 1 is 1. Hopefully we know that 32/1 is the same thing as 32. Okay. The next problem, fractions, but they start throwing in some that are more ugly because they've got negative signs all of a sudden. This problem is on page 66 of the first packet, and it's problem number 2. It's the same process we used before. We just have to pay closer attention because we've got the negative and we already have fractions on both sides. So right now I'm multiplying y by -2/5. To undo that, I'm just going to divide by -2/5. If I do it to one side, I need to do it, you know what, and I'm using the little division symbol that students are typically more familiar with. But I'm going to go ahead and use the fraction line because in algebra, you typically will see division written like that. So I'm going to divide both sides by -2/5. Okay. And then I'll rewrite my whole problem down here. And so again, -2/5 divided by -2/5. In order to divide fractions, we're actually going to multiply by the reciprocal or the flip-flop. So I'm going to rewrite this. I could put my negative sign either with the 2 or the 5, but I only get one negative sign. I'm just going to leave it on the top. -5/2 is the reciprocal of -2/5. Now we just need to multiply. Actually, let's do some cross simplification first of all. -5 divides by 5 leaves 1. 5 divides by 5 leaves 1. 2 divides by 2 leaves 1. -2 divides by 2 leaves -1 because I had those negative signs. Don't forget about those. Okay, so now let's see what we end up with here. -1 times by -1 is a +1, and we have our y. And then 1 times by 1 is 1. Oh, we're back to that same thing. That 1y over 1 is just the same thing as saying y. Okay, we need to do this division now. 7/8 divided by -2/5. Again, division is just multiplying by the reciprocal or the flip-flop. So I'm going to write -5/2 up there, and I'm going to multiply across. It's just easier for me to solve it that way. 7 times by -5 is -35. 8 times by 2 is 16. So our answer is -35/16. That is the correct answer, and that is a legitimate form to write our answer. A lot of times in algebra, you'll find that even though that's an improper fraction with a larger absolute value on top, it can be easier to work with if we had to use our answer for another problem. But if that bothers you and you want to turn it into a mixed number, we certainly could do that. We know it's going to be negative. 16 is going to go into absolute value of 35 2 times. That would be 32. And then I would have 3/16 left over. Both of those answers would be in the correct form. Okay, let's do another problem. Sometimes, just to kind of intimidate people, you might see something that mixes fractions with decimals. And this problem is on page 66 of the first packet. It's problem number 3. And we've got fractions and decimals. And I will tell you, it is not a good idea. Can you guys still see me?
Yes.
Okay. There we go. My computer went haywire. Okay, and you can still see the whiteboard. Great. Okay, so it is not a good idea to try to solve a problem with a fraction and a decimal in it. The best first step would be to either turn our decimal into a fraction or turn our fraction into a decimal. Personally, I think for this problem, although we could do it either way, it's much easier to turn 3/4 into a decimal. And so 3/4 is the same thing as 0.75. X equals 1.20. And if you didn't already know that, and you wanted to figure out how to turn a fraction into a decimal, and you're allowed to use a calculator, I know you don't always have that freedom, but if you did, you could do 3 divided by 4. And you could type that into a calculator and it would give you the answer 0.75. Okay, but I had that one memorized. It reminds me of money. 3 out of 4 quarters and $1 would be 75 cents. Okay, but now that I've got it written all in decimals, I just have to use my same system that I've been working with. Right now, my variable is multiplied by 0.75. I would have to divide by 0.75. Whatever I do on the left, I do the exact same thing on the right side. Okay, so 0.75 divided by 0.75 is just going to be 1. So that's going to cancel out. I'm just going to have my x left on the left side. 1.20 divided by 0.75. I'm going to use my scratch paper over here to solve that one. Okay, So now remember, before I start division, I have to make sure the number that I'm dividing by is a whole number. And it's not in this case, it's a decimal. So I have to ooch my decimal point 2 places to ensure that I'm dividing by a whole number. I did that here, so I need to do the exact same thing here. And this time I'm not going to forget, I like to put my decimal on my answer line before I even start the problem. So my decimal is going to go right there. Okay, so 75 into 1 is not going to work, into 12 is not going to work, but 75 into 120, I know that it will go in there one time, and I know that 75 times by 2 is 150. Like 75 cents times by 2 would be $1.50. Okay, so I know that that would be too much because I only have 120 here. I'm going to put down 1. I'm going to multiply, it's 75. I'm going to do my subtraction. This becomes 10. I'm going to borrow, that's a 1. Borrow again. I end up with 45. I'm going to bring down a 0. So now 75 into 450. Okay, I'm going to keep track. I'll keep track up here. I've got 75 plus 75. Well, I said I already know that is 150. I like to think of money plus another 75 is going to bring it up to $2.25 plus another 75 would bring it up to $3 plus another 75 would bring it up to 375 or $3.75 plus another 75 would bring it up to $4.50. Woo! Fortunately, that's exactly what I was looking for. 1, 2, 3, 4, 5, 6. I had to multiply by 6 in order to get 450. So 6 times by 75, we said was 450, subtract, got a remainder of 0. Our answer on this one, it took us a little longer to get there, but our answer is x equals 1.6. Let's look at another word problem. This is the first packet, page 67, number 6. As a salesman at Valley Auto, 5/8 of the cars you sell are foreign made. If you sold 50 foreign made cars last year, how many total cars did you sell? And they want us to write the equation, and they want us to solve for how many cars, total cars, were there. I'm going to use the letter C to represent the total cars. They didn't tell me this time, so I get to decide. C makes sense to me. Okay, so C is my total cars. As a salesman at Valley Auto, 5/8 of the cars you sell, of the total cars you sell, are foreign made. Okay, 5/8 of the cars you sell, or of the total cars you sell. So of translates to multiplication. So this number expression means 5/8 of cars times by cars. And we know that 5/8 of the cars are or equals 50 foreign cars. Okay, that's my equation. Now I just need to solve for how many cars. Again, I'm multiplying by a fraction. We need to divide by 5/8. I was multiplying by 5/8 here. That means I need to divide both sides of my equation by 5/8. Remember, when we're dividing by a fraction, it's the same thing as multiplying by the reciprocal. I can cross simplify, and I end up with just C on the left side. Same thing here, 50 divided by 5/8 I have to multiply by the reciprocal 8/5. Whoops. Multiply by the reciprocal 8/5, and it helps me to turn 50 into a fraction. I can cross simplify here too. If I divide 50 by 5, I have 10. If I divide 5 by 5, I have 1. 10 times by 8 is 80 over 1. Hopefully we recognize that 80 over 1 is the same thing as 80. So there were this man sold a total of 80 cars, and 50 of those were foreign made. Okay, let's try. I want to work a little bit more with negative numbers, just because you will see them a lot. And they're not difficult. You just have to keep track of more. This problem is from the first packet, page 68, number 6. Now, I intentionally put my B on the right side of the equal sign. Many times when you're solving equations that are much more complex than what we're looking at, you might end up, your variable might be on the right side instead of the left side. So I put it this way just so that you would get used to it. Doesn't matter. So this one, when I'm all finished, because I like as few steps as possible, I want to end up with B, but my B is going to stay on the right side. No reason to move it. And my value this time will be on the left side. Okay. Same thing we've been doing. B minus 3. I want B all by itself. Minus 3. Well, the opposite of that is plus 3. I'm going to add 3 to both sides. Minus 3 plus 3. That just cancels out. All I have left on the right side is B. But here I've got negative 7 plus 3. And when I'm working with students at seeds, these can be very tricky. I like, when I'm working with negative numbers, to think of things on the simple number line. So I'm going to put my 0 right there. My starting point for this problem is negative 7. So I'm just going to put negative 7. I have to add 3. If I'm adding a positive number, things are getting bigger, and anything getting bigger on the number line has to move to the right. So I know I'm going this direction. I'm at negative 7, and I need to go 3 jumps to the right. So I do it like negative 7. So negative 6, negative 5, negative 4. There's my 3 jumps. And I ended up at negative 4. So B in this case equals negative 4. Okay, I want to move into slightly more complex problems. But before we do that, I want to talk about substituting. I've moved on to the second packet, the packet that I believe it was called Algebra from the Contemporary book. A more complex equation might look something like this. 2y plus 5 equals 18. This is page 4 from the second packet. And I'm looking at problem number 1. Now, they gave us the more complex equation, and we're supposed to be solving, and they don't actually want us to solve it yet. They're saying, if I told you that y equals 6, is that the correct solution? Yes. Or is it the incorrect solution? No. So they've given us the answer, and they're saying, is that answer correct or is that incorrect? So the way I like to solve these problems, I'm going to rewrite it down here. Any kind of a substitution problem, I always tell students, write the problem in pencil. And I like writing it a second time, just in case you need to remember the original equation. I don't like to write over it. So Now, where that variable is, I'm going to erase that exact spot. And that is where I'm going to substitute in my potential answer, which is 6. Now, 2y, I know that that's multiplication. I understand that's 2 times by y. So if I just wrote the 6 there, it would look like 26. So I have to put the parentheses to represent that multiplication so that this still means 2 times by 6. Okay, so let's try that. So 2 times by 6 is 12 plus 5. And let me see, that's supposed to equal 18. 12 plus 5 is 17. Wait a second. 17 doesn't equal 18. 6 is not the correct solution, so I would circle no. For grins, I'm going to go ahead and show you how would we have solved this problem. That's another good strategy to use for something like this. You could solve it and find for yourself what y is supposed to equal, and then you'll know if their suggestion was correct or incorrect. All right, the most important thing when you've got a multi-step problem that you set in your head, when I'm finished, where do I want my y's and where do I want my numbers? So in this case, I already have all of my y's on the left side, so I'm going to leave them there. So my plan, I know I'm going to want y equals a value on the right side. So I'm leaving my y's. So now I can say to myself, I got a lot of stuff over here on the left side of the equal sign. I can only undo or move one thing at a time. Addition and subtraction of a number needs to be moved first. We're working through that PEMDAS, if you're familiar with order of operations. When we're undoing, kind of have to work backwards. So I have to undo any addition or subtraction first. So that means my plus 5, it's on the wrong side of the equal sign. I only want y's on the left. So I need to get that plus 5 to cancel out. So I'm going to subtract 5 because plus 5, the opposite is minus 5. Don't forget your balance beam. Put down your equal sign. Same thing on both sides. Plus 5 minus 5, that cancels. I just have 2y equals 13. Okay, now I've got a second step. I'm close. I've got all my y's on the left side, but I'm multiplying y by 2. And I really want y either multiplied by 1 or y all by itself is the way it's going to look. So to undo 2 times by y, I need to divide by 2. I did it on the left. I have to do the exact same thing on the right side. Okay, 2 divided by 2, we know that cancels. That's just going to be 1. That leaves me with my y. 13 divided by 2. You could work out the division, long division. We know that 2 can go into 13 6 times. 6 times by 2 is 12. I have 1. I bring down another 0. 2 goes into 10 5 times. 5 times by 2 is 10. Subtract 0 remainder. Oh, y actually equals 6.5. Okay. And I'm going to do one more substitution problem. This again is from page 4 of the second packet. 3x minus 19 equals 20. And they are saying x equals 13. Yes or no? Okay, I like to rewrite so that I can always refer back to my original equation. And now when I'm substituting, I'm going to erase right there where the x was. And in that spot, I'm going to substitute their suggestion, 36, of 13. So I'm going to put 13 exactly in that spot where the X was. 3 times by 13 equals 39 minus 19 equals 20. 39 minus 19, 9 minus 9 is 0, 3 minus 1 is 2. Oh, that's 20 equals 20. You know what? That one works out. So I'd like to put a little check mark to show 20 does equal 20. That answer is yes. Let's try some more multi-step problems. Let's see, let's think about n over 3 plus 3 equals 4. And this is from the second packet, and I'm on page 5 now. This is problem number 7. So again, when I've got a multi-step problem, the first thing I want to do is think about, when I'm all finished, which side do I want my n's on and which side do I want my values on? So I only have one n. I want to leave it on the left side, and that means that all of my numbers will be on the right side. This is a 2-step problem. You will eventually get to 5- and 6-step problems that have got variables on both sides. When you get to more complex problems, I call this my plan, because my plan is to end with n on the left and my values on the right. With more complex problems, I actually like to write my plan up above. And my plan is that the variables go on the left and the numbers go on the right, because now I can go through here. N over 3, yeah, that's an n, that's on the left side, it's where it belongs. Plus 3, that's a number. That doesn't belong on the left side. We want all the numbers on the right side. Plus, remember, we undo addition and subtraction first. So let me see, the opposite of plus 3, that's just minus 3. Do it on the left, I'm going to do it on the right. That's going to cancel, and I'm left with just n over 3. 4 minus 3 is 1. Okay, so now I've got n divided by 3 equals 1. Well, what's the opposite of dividing by 3? Multiplying by 3. If I do it on one side of the equation, I have to make sure I do it on both sides. Okay, so this is a fraction, and when I'm multiplying, I do find it easier to rewrite it side by side. And I also am going to turn my number 3 into a fraction, which would just be 3 over 1. So now, in order to multiply n divided by 3 times by 3, got it written side by side. Well, I can cross simplify. Those are just ones. Oh, look, I end up with 1n when I simplify all of that. But I still have to do this. 1 times by 3, and there's my equal sign. Don't lose your equal sign. 1 times by 3 equals 3. Instead of 1n, I can just write n is fine. N equals 3. You know what? Let's substitute to see if I have the correct answer. That's why they taught us substitution, is because when you get a problem that's kind of hairy like this, it's a good way to go back and see if you solved it correctly. Plus 3 equals 4. I rewrote my original problem, and now I'm going to erase where n was, and I'm going to substitute the number 3, because my solution that I came up with was n equals 3. So now we have to see if this is true. 3 over 3, well, I can rewrite that as 1. plus 3 equals 4. Oh, look. 4 equals 4. My answer was correct. We've been going quite a while. Tashonda, do you have any questions that I could answer at this point, or anything that you'd like me to work again, or new problems you'd like me to try?
No.
Are you feeling okay about this, or have you done algebra like this before?
Uh-huh.
Okay, good. Awesome. Okay, well, if there aren't any questions, that concludes this lesson on solving simple equations using multiplication, division, addition, subtraction. We had a little bit of exposure to working with negative numbers. We had a decent amount of exposure with working with fractions and working with decimals. And this is me. Thank you very
All right.
much.
Thank you. Have a nice day.
Yeah, you too. Enjoy yourself.
All right. Bye-bye.
Bye-bye.
That's your teacher? No. Bye, Todd. See you later.
Bye, Chana. All right, you can stop the recording now.
Oh, forgot that was me. Click stop. It doesn't want to stop. It says stop my recording.
Yeah. Oh, well, we'll just log out of the meeting.
Okay.
We'll stop then. So, all right. Thanks, Ann.
Okay. Thank you, Todd. Do you want